Hello everyone. In the revision of NCERT, now I am taking two important topics of weather systems. One is what is meant by adiabatic changes in the air column, and in the connectivity to it, the tropical cyclonic circulation. In the last video, I talked about temperate cyclone and the difference between tropical and temperate cyclone. After learning tropical cyclone, those differences will become much more clearer. Tropical cyclones, tropical storm and hurricane are the three technical names applied to this system. It is thermally induced system that develops in tropical marginal water bodies. What is its structure, which kind of weather effectivity it induces, and what exactly is the nature of atmospheric circulation will help us in concluding entire nature of atmospheric circulation that we should be aware of while taking the revision of weather systems. So without wasting much time, we are getting to the study of tropical cyclonic circulation and adiabatic changes in the air column. We want to begin with our study of what is meant by adiabatic changes in the air column. Adiabatic changes are defined to be change in the air temperature without any real addition or subtraction of heat. So question automatically gets generated, how I can change the temperature when there is no addition or subtraction of heat. So this comes with the reference of volume change. And if I have to put it like this, we all can easily understand. A rising air column will increase its volume due to expansion, and it is due to this expansion it will cool down. This cooling process is called adiabatic cooling. Another way of understanding it is adiabatic cooling is lapse rate of the air column. Which lapse rate we are talking about? Adiabatic. So how do I take the adiabatic lapse rate? Adiabatic lapse rate is cooling of the air column as it is subjected to rise. So in continuity, can we easily make another statement? Subsiding air column will be subjected to adiabatic warming. And we have already learned rising air will be subjected to adiabatic cooling. And adiabatic cooling is also referred as adiabatic lapse rate. Now concentrate on this figure. This figure shows 1000 meters of height, which is not necessarily always the constant one, but in this figure is the level of condensation. Level of condensation where latent heat will be released, and it is written here with the cloud. So if the air column is rising, so red mark in this figure, the air column is rising, and rising air column before reaching its dew point temperature. The temperature at which the air column becomes saturated, it's called its dew point temperature. So if the air column is warmer than its dew point temperature, it is which type of air column? It is unsaturated. An unsaturated air column cools at what rate? Dry adiabatic lapse rate. The dry adiabatic lapse rate equals 10 degrees Celsius per kilometer of ascent. I want to read it from the diagram. Dry adiabatic lapse rate is 10 degrees Celsius per 1000 meters of ascent. So when we talk about adiabatic lapse rate, how many types we distinguish? We have learned dry adiabatic lapse rate. What is dry adiabatic lapse rate? The rate at which unsaturated air column cools down. And what will be the definition of unsaturated air column? Definition of unsaturated air column is the air column which is yet to reach its dew point temperature. And how do I define dew point temperature? The temperature which is encircled here, the condensation level, the temperature at which the air column becomes saturated. Once saturated, release of latent heat. Released latent heat tends to retard the lapse rate. That is the reason the wet adiabatic lapse rate is just 5 degrees Celsius per 1000 meters. What is the reason wet adiabatic lapse rate is gentler than dry adiabatic lapse rate? Release of latent heat tends to retard the rate of cooling. So please note carefully the rate of cooling of the rising air column. Rate of cooling was steeper till condensation level, and after that the rate of cooling has become retarded. So quickly repeating, adiabatic changes as cooling is called adiabatic lapse rate. Adiabatic lapse rate has two types, dry adiabatic lapse rate and wet adiabatic lapse rate. Dry adiabatic lapse rate is experienced by unsaturated air column and wet adiabatic by saturated air column. Another way of referring it is dew point temperature, which we have seen with the diagram. Dry adiabatic lapse rate is steeper, wet adiabatic lapse rate is comparatively gentler. Another important fact, the normal lapse rate is the rate at which temperature decreases normally in troposphere. And what is normal lapse rate? It is 6.5 degrees Celsius per kilometer. Environmental lapse rate is the rate at which the temperature decreases in specific air column. What does that mean? Normal lapse rate and environmental lapse rate are not similar. Environmental lapse rate is variable. Normal lapse rate is normally 6.5 degrees Celsius per kilometer of ascent. So what are the two things that we have learned so far? I am quickly repeating it. We have learned normal lapse rate 6.5 degrees Celsius per kilometer is not same to environmental lapse rate, which is variable. Rate of cooling of air column. Adiabatic lapse rate is two types, dry adiabatic lapse rate and wet adiabatic lapse rate. Dry is steeper, wet is retarded. Both represents rate at which rising air column cools. Now, if I have to put it in a very simple expression, for any air column to continue to rise, this is my temperature decreasing with increasing height, I can use environmental lapse rate here. And this is the rate at which the air column is cooling as dry adiabatic lapse rate, and beyond dew point temperature, it is wet adiabatic lapse rate. If the air column continues to rise, does it not represent that air column is still warmer than the surrounding? If the surrounding is colder, then only this air column can continue to rise. If the surrounding will become warmer, it will become lighter, then this rising will pause. That is the reason, make very clear sense with atmospheric weather systems. Atmospheric disturbances are absolutely correlated with the fact instability equals wetter conditions. And what does that technically stands for? It simply stands for temperature is plotted on horizontal axis and altitude on vertical axis. So I have got temperature here and I have got height here. And are we noticing the rate at which the air column is cooling? So highlighting this rate of cooling first. This is dry adiabatic lapse rate, steeper. And then if I highlight this one, it is wet adiabatic lapse rate, the gentler one. Why wet adiabatic lapse rate is gentler one? Because wet adiabatic lapse rate is retarded, as there is always the release of latent heat. How to understand atmospheric conditions? Read it from here. When the environmental lapse rate is greater than dry adiabatic lapse rate, atmosphere is absolutely unstable. When the environmental lapse rate is less than the moist adiabatic lapse rate, the atmosphere is absolutely stable. We need to understand these expressions, stability and instability. I want to start with stability. So this statement is what I am highlighting as our first case to learn. So case number 1, what it is referring? It is referring that when environmental lapse rate will be less than moist adiabatic lapse rate. So what is moist adiabatic lapse rate? Wet adiabatic lapse rate. What is wet adiabatic lapse rate? 5 degrees Celsius per kilometer. Take the understanding like this. Environmental lapse rate is variable. So we are not standardizing its rate. And wet adiabatic lapse rate is the gentler rate of cooling of the rising air column. So if the environmental lapse rate is lesser than wet adiabatic lapse rate, what does that mean? That surrounding will be much warmer than the air column that is rising. So will it not be that the air column will become colder in due course of time and will stop rising? Such condition is called absolute atmospheric stability. So what is absolute atmospheric stability? When environmental lapse rate is less than wet adiabatic lapse rate. If environmental lapse rate will be more than dry adiabatic lapse rate, what is dry adiabatic lapse rate? Steeper. What does that mean? Surrounding will be colder and rising air column will be warmer. And such warm air column will experience steep convective rise leading to absolute atmospheric unstable conditions. And basically it is this absolute unstable condition with which we correlate tropical cyclone. Going to this diagram again. When the environmental lapse rate is less than moist adiabatic lapse rate, atmosphere is absolutely stable. So atmosphere is absolutely stable when the environmental lapse rate is less than moist or wet adiabatic lapse rate. So the pink color in our diagram. When the environmental lapse rate is greater than dry adiabatic lapse rate, the atmosphere is absolutely unstable. Environmental lapse rate is greater than dry adiabatic lapse rate, the blue patch. And then the third condition comes in. When the environmental lapse rate lies between dry and wet adiabatic lapse rate, conditional instability. Can you notice this is conditional instability? See this now? Temperature plotted on horizontal axis, altitude on vertical, environmental conditions and dry wet adiabatic lapse rate. Dry adiabatic lapse rate 10 degrees Celsius per kilometer, moist adiabatic lapse rate 5 degrees Celsius per kilometer. What will be this condition? Absolutely unstable. Reason? Environmental lapse rate is greater than dry adiabatic lapse rate. What is this condition? Absolutely stable. Environmental lapse rate is less than moist or wet adiabatic lapse rate. Conditional instability when environmental lapse rate is in between wet and dry adiabatic lapse rate. And what condition is where we talk about tropical cyclones like weather system? It by default will be with absolute unstable environmental conditions. The tropical cyclone, example of absolute instability. And this absolute instability technically stands for environmental lapse rate is greater than dry adiabatic lapse rate. So the air column is immensely warm and will rise abruptly. And this rising will create the instable, turbulent weather condition. So what we have learned as instability, we want to carry it forward from this. The tropical cyclones are violent storms that originate over oceans in tropical areas and move over coastal areas, bringing about large-scale destruction caused by violent winds, heavy rainfall and storm surges. This is one of the most devastating natural calamities. Tropical cyclones are violent storms because they put the example of atmospheric instability. Why they move over coastal areas? Actually, they originate over coastal areas because they require latent heat as the prominent source of their energy. What is the reason? They generate landfall. Remind yourself, in the last video I talked about tropical cyclones moves in the influence of trade wind, and this is the reason that they move towards land on the eastern coast. And because they are known for strong winds, heavy precipitation and also the onshore winds creating sea surges. So it gives us these three factors as the cause of it being a destructive system, causing large scale devastation in the coastal area. Before I read the next statement, I want you to see this diagram. Tropical cyclone essentially originates in Gulf of California, Gulf of Mexico, South and East China Sea, Arabian Sea, Bay of Bengal, Mozambique Channel, and Coral Sea Gulf of Carpentaria. These are the areas where this system is prominently or majorly developed, and it is in these areas the system has got variable names, and these names is best learned as: in United States of America, tropical cyclonic region number 1, the system is called hurricane. In Indian Ocean, namely Arabian Sea, Bay of Bengal, Mozambique Channel in south, it is called cyclone. In China Sea Belt, including China, Taiwan, Philippines, the system is called typhoon. And in Australia, Papua New Guinea, the system is called Willy Willies. So basically, when we talk about this system in terms of their place of origin, we identify them with variable names, and these names I read from NCERT. They are known as cyclone in Indian Ocean, hurricanes in Atlantic, typhoon in Western Pacific, South China Sea, and Willy Willies in Western Australia. So how do I identify tropical cyclone? Tropical cyclone is an example of absolute instability. It originates over tropical marginal water bodies. Tropical marginal water bodies in Indian Ocean makes this system called cyclone. In United States of America, it becomes easier because if I read it from our NCERT, hurricane in Atlantic Ocean, USA, both Atlantic Ocean and Pacific Ocean, I am calling it hurricanes. And if I take the step further, in Pacific Ocean towards Asia, so I am taking it as China Seas because I am including both South China Sea and East China Sea, not completely, and we are calling them typhoons here. And additionally, what NCERT gives us in Australia, so marginal water bodies to be seen here is Carpentaria Gulf, marginal water body to be seen here is Coral Sea. So these are not that popular examples, but it is also there, we call it Willy Willies. Then NCERT reads, tropical cyclones originate and intensify over warm tropical oceans. We know that water always maintains its temperature. That is the reason when I say warm tropical ocean, I am essentially talking about marginal water. Because it will only be in marginal water that we will be developing desired temperature conditions. And what are they? Let us see it. Large, the conditions favorable for formation and intensification of tropical storms are: number 1, large sea surface temperature higher than 27 degrees Celsius. It will be typically confined only in marginal water. Number 2 says presence of Coriolis force. 3 is small variation in vertical wind speed, and 4 is a pre-existing weak low pressure area or low level cyclonic circulation, and 5 is upper divergence above the sea level system. Now to understand it, 2 becomes very evident. Number 1, that I require high temperature because it is a thermally induced system. So if this thermally induced system requires temperature of more than 27 degrees Celsius, why it is essential for me to talk about marginal water? Because I attain entire of my energy from release of latent heat. So there is the requirement of moist air column. That is the reason water bodies. And what exactly is this? Low level cyclonic and upper air anticyclonic conditions or divergence. We'll understand it with this diagram. This is my warm water, where the low pressure has got developed. Due to Coriolis force, there is counterclockwise convergence that is taking place By default, we are in northern hemisphere. Low pressure relates to rising air convection. So, convergence counterclockwise on ground, rising air convection will result into divergence clockwise in upper air, outflow. And that will be clockwise. So, what is the nature of circulation that we see with tropical cyclone? Counterclockwise convergence low. Every low will vertically overdevelop high. So, every low pressure is convergence and every high pressure is divergence. So, which type of divergence I will be having in upper air? It will be clockwise divergence. See more depictive diagram here. Counterclockwise convergence and rising air column, which tends to develop latent heat release causing air to expand and surface low to strengthen. Frictional convergence of moisture causes rising motion, and this low is the beginning low that is developed due to warm ocean. We can easily call it the preliminary stage of development of tropical cyclone. What is this preliminary stage characterized with? It is characterized with the development of low pressure on the warm surface of water, which results into the rising of the air column. Rising air column tends to generate release of latent heat, as you can notice the formation of cloud which is visible here, and release of latent heat tends to provide the further energy for the system to grow. In the continuity of this system's development, that is low pressure again here, I can again notice counterclockwise convergence which is taking place here. The system in its mature stage, so we are now talking about mature stage, tends to develop what? Don't miss to see out this spiral of air and the divergence that tends to develop in upper air. Air flows outward and Coriolis turning forms upper anticyclone. And don't miss to see out these expressions written here. As the surface low strengthened, moist frictional convergence, convection and surface low have a positive feedback on each other. Wind strengthen as low develops frictional convergence. Strong convection gives more latent heat. So, the entire system becomes significantly turbulent and generate cumulonimbus and cumulus clouds. I am going back to NCERT. Small variation in vertical wind speed, a pre-existing weak low pressure area and upper divergence above the sea level system. So, the developed low pressure intensifies itself due to release of latent heat. So, every convergence on ground tends to develop divergence in upper air, and this results in primary circulation, that is spiral convergence of wind counterclockwise to the low pressure area. We are by default in northern hemisphere. And secondary circulation, which will be correlated with outflow in the upper atmospheric location. Don't miss to see, it has to be anti-clockwise. Circulation nature in tropical cyclone thus is demarcated as two: primary convergence, secondary upper air divergence. In the support of simple diagram, we can understand it as, this is my low pressure center and I am in northern hemisphere, so the convergence will be counterclockwise. This is my convergence. Which circulation we have taken into account? This convergence will be called primary circulation. And if I take a cross section of it and attempt to draw a miniature here, I have taken cross section A and B and A and B here. So what exactly it is? In will be up, every low pressure will vertically overdevelop high pressure, and up will be, out will facilitate down. So divergence at upper air, convergence in the surface. And what is nature of secondary circulation? Secondary circulation will generate the rain bands. This is the belt of rain bands, and this is eye of the cyclone. Now see the diagram again. Convergence, rising, don't miss to see the cumulonimbus clouds and cumulus clouds that are being drawn here. So what are these? These are your rain bands, and this is my eye of the cyclone, which is the low pressure center, where I am noticing the rising convection. This is high pressure vertically over, where I am noticing divergence, outflow. And rain bands, right here we have got all rain bands. Rain band 2, 3. Counterclockwise convergence, spiral of air, noticing upper air divergence. And this is my eye of the cyclone that remains windless, cloudless and rainless, and is surrounded by all rain bands, cumulus cloud, cumulonimbus cloud. And this is the spiral that we notice. Of course, we need to see that the circulation will be counterclockwise. In this two-dimensional figure, in and up, out and down. So this is my high pressure over this low pressure of the eye of cyclone. And this calm, rainless, cloudless zone is also with weak subsiding air convection. Don't miss to see the water body where the system marks up its development. Structure. So how many structural constituents are there in tropical cyclone? It is eye and rain zone. What is eye characterized with? It is characterized with highest temperature, lowest pressure, warm anticyclone developed in upper air that will generate divergence. It will have a weak subsiding air column and will have surrounding eye the cumulonimbus and cumulus cloud causing heavy precipitation. Don't miss to see out the rain zone here. NCERT. The energy that intensify the storms come from condensation process. I have told you in the beginning, release of latent heat. In the towering cumulonimbus cloud surrounding the center of the storm, with continuous supply of moisture from sea, the storm is further strengthened. On reaching the land, the moisture supply is cut off. Very important statement, putting on the star mark, and the storm dissipates. Why tropical cyclone dies after landfall? Because latent heat is not available. So the primary reason for tropical cyclone to not exist over land is that there will be lack of availability of moist air. This is very important. So, where do we experience tropical cyclonic circulation and its effectivity? It's in coastal areas. The place where tropical cyclone crosses the coast is called the landfall of the cyclone. The cyclone which crosses 20 degrees north latitude generally recurve and they are more destructive, recurving largely with the favorable pressure gradient force. Mature tropical cyclone is characterized by strong spiral circulating wind around a center called the eye. The diameter of circulating system can vary between 150 to 250 kilometers. The eye of this region of calm with subsiding air. Around the eye is eye wall where there is a strong spiraling ascent of air to greater height reaching the tropopause. The wind reaches maximum velocity in this region, reaching as high as 250 kilometers per hour. Torrential rains occurs here. From eye wall, rain bands may radiate and trains of cumulus and cumulonimbus cloud may drift into the outer region. The diameter of storms over Bay of Bengal, Arabian Sea and Indian Ocean is between 600 to 1200 kilometers. The system moves slowly about 300 to 500 kilometers per day. The cyclone creates storm surges and they inundate the coastal lowlands. The storm peters out on land. Eye of the cyclone. Low pressure system. Air converging, rising. Rise being strongest along the eye. This is what is being marked in our NCERT as eye wall. And eye wall facilitates this outflow with rain bands. Cumulus cloud, nimbus cloud. Don't miss to see the rain band here. This is my high pressure which eventually will facilitate subsiding air. So, outflow, in is up and out will be down. Rain band will be developing along and beyond eye wall. And what will be this funnel? This funnel is windless, cloudless, rainless center of the system called eye of the cyclone. That is the reason the satellite images gives us tropical cyclone with a spiral of the cloud like this. And where will be having the eye? This is the center of the system. And as will be moving beyond, it will be from cumulus to cumulonimbus. This is all rain zone. The tropical cyclones, we can add one more thing to our understanding which we have already referred in our learning of this system, that we actually technically use three terms to denote this system. Technically. So, technically storm will be the weakest system. This will be of the moderate strength and this is the intense most. It will be very wrong for us to say that every storm will become hurricane or that every hurricane to begin with was storm, but the tropical cyclone in terms of its intensity is categorized into these three categories technically. So, never be confused with the usage of the term hurricane. Two terms written here, hurricane and cyclone, have twin usage. One is their regional name and two is their technical name. So, regionally, whether it is tropical storm, cyclone or hurricane, if it is in Indian Ocean, it will be called cyclone. Regionally, if it is in Gulf of Mexico and Gulf of California, it will be called hurricane, which can be of all the three intensity. So, never be confused with the usage of the term hurricane. Hurricanes of USA can technically be storm, cyclone or hurricane. So, you have to be clear with this. And in context of India, we can add one more expression to it. IMD identifies 7 different categories of tropical cyclonic circulation. I have talked about it in earlier videos also, you can take reference of them. So, we in India call every of such system as cyclone, but based on the intensity of sustained wind velocity. You can see if it is more than or equal to 221 kilometers per hour, we call it super cyclonic storm. If it is weaker than that, then it is extreme severe cyclonic storm, very severe cyclonic storm and severe cyclonic storm are the top 4 categories. And then cyclonic storm, deep depression and depression are the other 3 categories. So, how many categories we demarcate the tropical cyclonic circulation of our country? The Indian Meteorological Department identifies 7 different categories of tropical cyclonic circulation based on intensity. I am renaming them in decreasing order of wind velocity. It includes super cyclonic, extreme severe cyclonic, very severe cyclonic, severe cyclonic circulations along with cyclonic storm, deep depression and depression. So, this is a technical edge that I can add with IMD. Otherwise, in the global perspective, we identify the system to be of 3 types: storms, tropical cyclone and hurricane. That is it for this video. Happy learning and all the very best to all of you.